Here we have a problem from the South Carolina 2017 math contest, and it asks us how many integers satisfy this equation, where the equation is n to the fourth plus 6n is strictly less than 6n cubed plus n squared. So let's jump into the solution. What we want to do is move everything to the left-hand side of this less than symbol here. So we'll have n to the fourth minus 6n cubed, that's by this term moving over here, minus n squared, that's by this term, and then plus 6n is less than 0. But now the way we solve for these kinds of inequalities is we factor this polynomial and then look for the ranges between the zeros that satisfy our condition here. So we can factor n out first because all the left-hand side terms contain an n. That gives us n cubed minus 6n squared minus n plus 6 is less than 0. So we know that n equals 0 is a 0. And I'll go ahead and put all the zeros over here in blue. But now we need to factor this cubic equation here. And I'll go ahead and do that using a combination of the rational root theorem and synthetic division. So the rational root theorem tells us that we're going to need plus minus 6, plus minus 3, plus minus 2, or plus minus 1 as our possible rational roots. And I'll just pick the lowest hanging fruit. I'll check the term x minus 1 and see if it's a root. So the way we're going to do that is we'll have 1 here. And then we'll have our coefficients for this cubic over listed like this. And then we bring our first term down. And then we multiply and add. So we'll have negative 6 plus 1, that's negative 5. Negative 1 minus 5, that's negative 6. And then negative 6 plus 6 is 0. So our term x minus 1 is indeed a root. And the resulting polynomial we get from it is x squared minus 5x minus 6. And we can pretty quickly look at that and find that the remaining roots are negative 1 and positive 6. So I'll go ahead and write those roots up here. We have 1, we also have positive 6, and we also have negative 1, like that. Okay, great. Now I'm going to get rid of all of this calculation, and we're going to draw a number line with these zeros on it, and then check the ranges between the zeros to see whether they satisfy this inequality. Okay, so here we have our number line, and so we want to check all the integers less than negative 1, all the integers between negative 1 and 0, all the integers between 0 and 1, and all the integers between 1 and 6, and finally all the integers that are greater than 6. So let's start over here on the left, and we can test with any integer we want. So let's test with negative 2. It's just the first integer after negative 1. So we'll have a negative 2 to the fourth power plus 6 times negative 2 is less than 6 times negative 2 cubed plus negative 2 squared. Now let's simplify this a bit. This is going to be 16 plus negative 12, so this will go to 4 eventually, but I'll leave it like that for now. And this is less than 6 times negative 8 plus 4. So this here that I'm underlining in blue is going to simplify down to 4, and that will be less than negative 48 plus 4, which is negative 44. But negative 44 is not bigger than 4. So everything to the left of negative 1 here is not a solution to this inequality. Okay, let's erase these and keep going. So now let's test our second range. We have between negative 1 and 0, but there's no integers here in this range or in this range. So we don't have any solutions there either. And now we only have 2 ranges to check. We have to check if 2, 3, 4, and 5 satisfy this inequality, or if any number is bigger than 6 satisfy this inequality. I should say any integer is bigger than 6, because that's what we're looking for here. So let's check 2. So we'll have 2 to the fourth plus 6 times 2 is less than 6 times 2 cubed plus 2 squared. So 2 to the fourth is 16. 6 times 2 is 12. 2 to the third is 8, so this will be 48. And 2 to the squared is 4. So this will be 28 here, and this will be 52 here. And this checks out because 52 is indeed bigger than 28. This is a true statement. So every number in here gives us a solution. But we're only looking for integers, so far these solutions are n equals 2, 3, 4, and 5. I'll go ahead and let you guys check if 3, 4, and 5 satisfy this inequality up here. Okay, let's move on to any numbers bigger than 6. So let's check 7, because 7 is the next largest integer after 6. So we'll have 7 to the 4th plus 6 times 7 is less than 6 times 7 to the 3rd plus 7 squared. 7 to the 4th is equal to 2,401. 6 times 7 is 42. 6 times 7 cubed is 2058. And then 7 squared is 49. So this number here will be 2443. And the number on the right simplifies to 2107. But this number on the right is clearly smaller than this number on the left. So this inequality is not true, which means there are no solutions bigger here than 6. So our only solutions are n equals 2, 3, 4, and 5. And any real number between 1 and 6 would also work. And we also didn't check these ranges because we're looking for only integers here. So these are our only integer solutions for n. And that's enough for now.